In this lecture, we are going to describe and study the error and uncertainty, the types of error which are three. Next, we will study significant figures, the rule of significant figures, and we will also study the precision, accuracy, and uncertainty in their relation with the least count, and we will do numericals on it, simple numericals. Next, we will study uncertainty and simple pendular or time period relation. Next, the dimension, we will study the dimension, the tricks of the dimension, how to find the dimension, in the special case of dimension that are power, rule, or many other rules. Now, let's subscribe and now watch the lecture. So, let's start. Bismillahirrahmanirrahim. Today we will discuss chapter number first in its second lecture. So the topic is error and uncertainty. So all the measurements that we do or that we calculate in physics are uncertain to some extent. These are uncertain to some extent. Uncertain mean there is some possible error. There are some possible error, and it is quite difficult. It is quite difficult to eliminate all the errors. Why it is difficult to eliminate the error? Because there are some most common or most possible reason for this. Possible reasons. Due to the reasons of error, we can't remove the errors from full measurements. So in a measurement, the error may occur due to, now these errors may occur due to negligence, mean negligence if we don't perform the experiment with care. The next is inexperience of a person. If a person is not much experienced or he is not much experienced and he is performing the experiment first time or second time, then he will perform some mistakes and this will cause the error in measurement. So negligence and inexperience can cause the error. Or when someone is using a faulty apparatus, so when our apparatus is faulty or there is some damage in our apparatus or our apparatus is out of order, so if our apparatus is out of order, so then there will be error in our measurement also. Or there are some also render error, like in some calculation the temperature, pressure, or these value also affect the error. So on the basis of reasons, we have divided the errors into three types, like types of error. So the first type is called personal error, or that is due to some personality or someone who is performing the experiment, or error due to him. So if someone is performing an experiment or someone is doing a calculation, so the error due to carelessness. So if someone is performing experiment and he is careless, or due to his negligence, or due to improper knowledge, so improper knowledge, so the error due to carelessness or improper knowledge about an instrument or incorrect reading from a scale can cause personal error. Or if suppose the reading is right, this is a scale, like the reading is 1 2 3 4 or something, and someone cannot calculate or he didn't put this value, or someone get an incorrect reading, so incorrect reading is also due to it comes in personal error. So this is the type of personal error. The next type is systematic error. Systematic error, as the name show, if there is an error in the system, then this type of error is called systematic error. Or if the apparatus used is faulty, it is damaged, there are some disturbance or poor calibration, or it doesn't give much accurate reading. So if the problem is in system, we call it systematic error. The third one is called random error or accidental errors. Random or accidental error. Accidental error. So the error due to repeated measurement of same quantity under same condition that the result of values are different, so this is called random error. For example, if we are performing an experiment and again we get different value. For example, if we do experiment and we get value of volume 12.24 meter cube, and next time we perform experiment and we get 1.5 meter cube value. So we are performing the same experiment at same time, but there is error. Now that error arises due to natural imperfection of an experimenter or limitation of apparatus or sudden change in environment. So the main cause of random error is sudden change in environment. Change in environment. Because if we are doing an experiment, due to the time of duration, if we again and again we are doing an experiment, so the time may changes because changes occur in environment. This is normal. So this type is called random or accidental error. So these were three types of error. Now goes to next topic, that is significant figure. The next topic is significant figure. Significant figure. Significant figures. So in any measurement, the numbers of accurately known digits in the first doubtful digits are called significant figure. So what are significant figure? Accurate digits. Accurate mean that are confirmed, that are fixed, that are true values, plus first doubtful figure. The one at which we feel about doubt are there, the error may be possible, but we will write only the first doubtful figure and accurate. Now there are some rules. There are some rules. For example, number 1. All non-zero digits are significant. For example, from 1 to 9. These are significant. For example, if we have number 1, 2, 3, so the number of, if we have number 1, 2, 3, the number of significant figure is 3. If we have number 12.5, so the number of significant figure are again 3. If we have 199, again we have significant figures of 3. So this was according to rule number first. Rule number second is, if we have number in the power of 10, like 2.8 multiplied 10 raised to power 30. So all the number are significant except the power of 10 and 10. So here are two digits, number 1 and 2. So if we have number 2.8 multiplied 10 raised to power 10, so the number of significant figure in this case are 2. Or if it is 5 multiplied 10 raised to power 50, so the number of significant figure is 1. Or 5 multiplied 10 raised to power 20, again the number of significant figure is 1. The next is, if there is decimal or rules for 3 number for 0, the 0 between non-zero digits, are significant. Like if we have 1001, so there are 4 significant figure. Out 2002, so there are again 4 significant figure. Or 101, the number of significant figures are 3. Now rule number 4th, 0 to the right of decimal. For example, if we have decimal and 0 to the right of decimal, 0 to the right of decimal, and 0 to the right of decimal and to the left of non-zero, and there is non-zero digits like 1, 2, 3. So these 0 are the right of decimal and these are the left on non-decimal number. So these are not significant. And the significant are 1, 2, 3. So in 0.0001, the number of significant figure is 1. Or 0.000123, The number of significant figures are 3 or 0.00629. So the number of significant figures are again 3. So 0 to the right of decimal and to the left of non-zero decimal are non-significant. Now, if the 0 is to the right of decimal and there is non-zero number, for example, there is non-zero number but there is decimal and points 0 are present on the right of decimal, 0 are present on the right of decimal, and there is non-zero number on left of decimal. So in that case this will be significant or not. So these will be significant, these 0 are not, but these will be. Why? Because these 0 shows us least count of the measuring instrument. For example, if we have two measurements, the first measurement is 100, the second measurement is 100.000. So this 100 means that it is measured by some instrument of which least count was 1 to 1. So the least count was, so the measurement was given is 1 2 3 4 5 6 7 and then it reached to 100. While this number shows us that the least count was 0.0001. So the instrument count this number starting from 001, 002 and so on, such that the 100 reached here. So the point 0 to the right of decimal and to the left of non-zero number are significant because these show us the least count. In this case the least count of the instrument was 0.001 or 10.10. 0 mean that this count of the instrument was 0.1. So 0 to the right of decimal and to the left right of decimal and left right of decimal, and there is non-zero number on decimal left side, so the number will be significant. So for example, if there is 80.0000, so how much significant figures are 1 2 3 4 5 6. So there are total 6 digits number. The next is if we have value in a unit, for example 8000 meter or 8000 kg. So this value will depends on the least count of an instrument. So if we have two cases, if we measure it by a least count instrument such that its least count is 10 or 1, in the next case if the least count of instrument is 10, in third case if the least count of the instrument is 100, and fourth case if the least count of instrument is 1000, if we want to measure 8000 meter. So in that case the first step is we will divide 8000 by least count, the given value by least count. In this case given value is 1000. So 8000 kg divided by 1 kg. So kg cancel with cancel, we will get 8000, which is simply number, and 8000 is there are 4 significant, 1 2 3 4. In next case if least count is 10, so 8000 kg divided by this count, that is 10 kg, 10 cancel, kg cancel, 0 cancel with this, and we will get 800, where 800 have 3 significant figure. So in 100 case we will get 80, that is 2 significant figures, and if we have 1000 kilogram the least count, so 8000 divided by 1000, kg cancel with kg, so we will get only 8, and there are 1 significant figure in 8000 meter. So this was easy. The next is if they give you two numbers such that to add it or to divide it, and then ask you to write the result in precise result. For example, so there are two rules. For example, before that we know that what is precise measurement. Precise measurement is that measurement of which least count is smallest. For example, if we want to measure a distance of 100 meter, so if one instrument give us result like 100.0 or the second instrument give us 100.000, so this means that the least count was 0.1, and this means that the least count was 0.000 1 0 0 1. So in this case, is the least count are small, so the value is or the result is high precise. So precise or precision is inversely proportional to least count. So bear in mind this formula. So precision is inversely proportional to least count. Now if we have a case, if they give us two values, so there are two cases. The first case are a number case, that is for plus and minus or addition or subtraction. In the second case is multiplication or division. So in positive and negative or addition and subtraction, the result obtained from addition or subtraction of measurement is retained to the measurement which is least precise. Least precise. So bear in mind least precise. Least precise. So we will give the result will depends on that value of given value which is least precise. So for example, if we want to add 3.5 centimeter and add it with 8.735 centimeter and another is 9.73 centimeter. So first of all we will find the least precise. So precision is inversely proportional to least count. So precision will be least if least count is high. So in this case least count is 0.001. So here in this case 3.5 is least count of 0.1. In this case 0.01 is the least count of this given value. So as we can see that 3.5 centimeter is least precise. This is least precise because its value is high. The least count value out of 0.01, 0.001, 0.1 is high. This value is high, so it is precise value. This is least precise. It is least precise because its least count is high, and by this formula, if least count is high, then precision will be low or least precise. So this formula we use, and out of these three values we knew that least precise value is 3.5 centimeter because its least count is 0.1. Now if we add it, our answer is 21.965. So we will round up this number to this because in given value this number is least precise, so our result must always compare with least precise. So 3.5 centimeter is two values. So this is two number 1, 2. So the number of significant figure and the result must also be equal to this. So or we will write the result in least count of the least precise value. So here the least count is 0.1, so we will write only one number to this. Now rounding up we will get 22.0. So the correct answer is 22.0, not just 22, because this was least precise. Now the trick is, if you forget this formula that what is precise and what is not precise. So in addition or subtraction you will see that the less number present after the decimal must always equal to in the result. For example, if we have this number 10.1, 10.01 or 10.001, so the answer is 30.111. So in addition or subtraction is in these three number there is only one number after this decimal, so the result must also have one number after decimal. So we will clear these two numbers. So this is the correct answer, 30.1. So in addition and subtraction just check the number after decimal. As this number is less, so in the result there will be always same number after decimal. So this was for addition and subtraction. While in multiplication and division, we will count all numbers. Or in multiplication and division, the final result is limited to the number containing the least number of significant. It is limited to numbers, least numbers. Least number mean we will count the numbers. For example, in 100 we have 3 numbers, while in 10 we have 2 numbers. So in this case we will count the numbers and the result will be limited to least number. For example, multiplying 3.6, if we multiply 3.6 with what? 3.856, so the result is so much lengthy number, like 13.886150. So in multiplication division we will count numbers. So 3.6 has 2 number, while 3.856 is 4 number. So our result is limited to least number. So the result must also contain 2 number, because in given number there was 2 number. So to make, we can also write this as 14.0 or 13.9. So 13.9 is equal to 14. So the correct answer is 14. So this was about, in the same rule is for division is multiplication. In the summary is that for addition and subtraction, we will see the number after decimal, that how much number this is. But in multiplication and division we will count the whole number, that how much the numbers are. So this was all about significant figures. So there was a teeny topic, small topic remaining, that was rounding of numbers. So rounding up numbers means writing a large number in a small form if it is after decimal, or if it is very lengthy number after, or it is very small number. For example, if this is number like 12.3434311, so there is many number after decimal, so we want to ignore it. So there are rules for it, and depend upon the number that we want to round up. So if the dropping digit is, there are 3 cases. If we want to drop this number, for example, or this, so there are 3 cases. If the number is, either the number is less than 5, or it is 5, or it is greater than 5, In this case, we want to round up this number to 0.23. So as the 4 is smaller than 5, then our answer will be 12.3. Or if our number is 22.41, so as if we want to drop these number or round up these numbers, so as 4 and 1 are small, 4 is smaller than 5, so we can write as 22. Our common sense, this is, if we get some value 14.2, so we can say that it's okay if we write 14. So rounding up numbers for less than small number, this is also rule, but for common sense we can also say that the rounding up number is 14. So this was first case. If the number is less than 5, then without making any change, we will just drop out the number. Now if the number is greater than 5, then what we say? For example, if we have result 14.9 say, so instead of 14.9 say, we write 15, because 14.9 is near to 5. Now it depends upon the number of dropping. So if we want the number and this number is greater than 5, like 14.6, 14.7, 14.8, 14.9. So if we want this number that is greater than 5, this number, in all cases we will write increase the number. So we will just increase the forward number. So in this case it will become 15. If this was 14.4, so as 4 is less than 5, then we will not make any change. So 14.4 will be equal to 14.14, or if 14.3 will be also written as 14. So this was case number 2. Now what? If the number is greater than 5, this is for that case. Now case 3, if the number is equal to 5 and if we want to drop it. So there are many two possibilities if the number is 5. For example, if we have a number like 12.345, or in another case if we have 12.305, 12.3500 and 12.3501 or 12.3502, or this is 5.05, or if we want to write another example like 15.15, 15.25. Now another number like 16.500, 1500. So these are the example if we want to round up the number in the last digit is 5. So there are two cases. There are how much cases? There are two cases. Further, in case first, if the last digit is 5 like this, there is, we want to drop out this 5 like this 5, this 5, this 5, this 5. If the last number is 5 or there is 0 after 5 like this 5, so there are two zeros like this, there are 5, 2 0, there is 0 1, so this will be not considered. So if there is 5 at the last or there are 2 0 at the last, so in such case we will observe. What will we observe? We will see the next number to 5. For example, here is 1, this is 2, this is 1, this is 0, this is 4, this is 0, this is 3. So if this number is even, there will be no change, but if this is odd, it will be increased by 1. So this case 16.1 will become 25. If we want to round up to 5, so 5 is removed, so 1 will increase by 1 because this 1 was odd. In this case, if we want to draw 5, so 15.2 will be answer because 2 is even. So in even there will no change. In case of even there will no change. If there is odd number after 5, so there is increase in 1. All these two cases are for what? If the dropping digits is 5 or there are 0 after the dropping digits. So in that case, if the number next to 5 is even, then it will be retained, and if this is odd, then there will be increase in by 1 in this number. In this case 15.1 will become 15.2 because this was odd and the digit was 5. In this case 0 is odd, so this is 5 point, this is even, so 5.0. The next is 12.345, so it will be retained because it is even. The next is 12.30 answer. Next is 12.3 will become 4 because this is odd, so this is 12.35. So in this case there are all in numbers after 5, so this is case number second. This was case first. If the number is 5, so in case first, this was case first, and these are case B. So in second case, if there is non-zero number after 5 like 501, 502, so this number will be increased by 1 without observer. If it is even or not, it will increase, like in this case it will become 12.45 and this will become 12.5, this is 12.4. If next number is 12.45, so again the answer will be 12.5. If this is 13.6, so the answer will be 13.7. So this was all about rounding up. The next is simple topic. The next topic is precision, accuracy and uncertainty. So first of all, precision. The term precision and accuracy both are sometimes used as frequently. These are sometimes used as interchangeably. So but there is clear cut difference. For example, the precision is related with what? This is related with least count. Uncertainty is also related with least count, and we can say that the precision is also related with uncertainty, because precision and uncertainty both are related with least count. The next is accuracy. Accuracy is related with fractional error. So if the least count is, talk about precision, so if the least count is small, more will be the value precise. If the least count is large, the number will be less precise. For example, these are two values like 10.1 centimeter, and the next case the value is 10.00001 centimeter. So this value shows that the discount of an instrument was 0.1 centimeter, and this shows us the discount of an instrument was 0.00001 centimeter. So this is, in this case, is the discount is very small, so it is more precise. In this case, precise mean more correct. So if you want to measure, so someone can tell you that what is, if someone asks you what is your percentage, and you tell him that my percentage is 19.000129, so he will say that this is best calculation, so this is correct calculation, and this like this 0.00001 centimeter. In this case the least count is small, so this is more precise. Everybody need precise result. So precision is related with least count. Small the least count, more will be at the precise. The next is accuracy. Accuracy mean the fractional error. If the error is small, so then it will be more accurate. Error is small, then it will be more accurate. If the error is large, then it will be less accurate. So the precision, and the term precision is related to least count, and precision and least count are inversely proportional to each other, while the term accuracy is related with error, and it is directly proportional to error. So greater the error, and it is also inversely proportional to the error. Greater the error, greater small will be the accuracy. So it is also inversely proportional to the error. Now smaller the magnitude or fractional error, better will be accuracy. So smaller the error, better will be accuracy. So if the least count is small, so there will be no error in the number. Now what is uncertainty? Uncertainty is direct the least count of value. For example, this is least count, so there will be less uncertainty in this value. So directly we can say that uncertainty is just the least count of an instrument. There is no need for uncertainty. Uncertainty mean maximum possible error. So how much error is possible in result? It depends upon least count. For example, if someone can measure number of students by 1, so if there are 10 students and we are measuring it 1 by 1, if these are 10 students, 1 2 3 4 5 6 7 8 9 10, and my discount is 1, I can measure 1 by 1, so 1 2 3 4 5 6 7 8 9 10 11. So there is error of 1 possibility, I make error of 1, so the error is dependent upon least count. So the maximum possible error is equal to least count, and the maximum power is called uncertainty. So indirectly uncertainty is related with least count, and precision is also related with uncertainty. So the whole cycle is just like the maximum possible error. The maximum possible error depends on least count, while maximum possible error is called uncertainty, and precision is equal to uncertainty. So these are the relations. Now for example, If the diameter of solid cylinder is measured with vernier caliper 22.0 centimeter and its length is 3.5 centimeter, find volume and possible accuracy. So this is was simple, just by rounding up. But what if you want to find uncertainty? There are special formulas, or there are different cases of uncertainty. So the possible types or the possible conditions for uncertainty are as follow. For example, if you want to find uncertainty in product rule or quotient rule. For example, there is no need to remember this types like quotient and product and others. So if you want to find uncertainty, so it depends on its formula. Like books, they give us V is equal to IR. So find the uncertainty in Y. So the uncertainty in V depends upon the uncertainty in I and R. And I and R uncertainty mean the maximum error. So if the error is R, maximum possible error is 10 and maximum possible error in I is 5. So how much error can occur in V? So if special cases, if we consider that in R there were maximum error of 10 and in I at the same time the error occur in it, that was 5, so 10 plus 5 is equal to 15. So the error in V will be 15. So this is for product rule. Now according to V is equal to IR, so if we want to solve this, if for example we have a voltage of 7.3 volt and its value or least count is 0.1 plus minus 0.1 voltage, and we know that I is equal to 2.73, so from this value we can write that its least count is 0.01. so this is least count, and least count is directly proportional to precision, or least count is related with uncertainty. So if we want R with accurate value, R is equal to V divided by I, so this divided by this, we will get our answer is 2.7 ohm. But this value is uncertain to some uncertainty value. So the possible error we will write it how much error is possible in 2.7. So the possible error in 2.7 ohm or 2.7 R depends upon V and I, and the error in V and I we will find from least count. So the error possible error is equal to percentage error in Y plus percentage error in I. V and I, percentage and V. So how much error in percentage can occur? So we will find it for this. So the value is 0.1 and the total value is 7.3. So multiplying 0.5, 1 divided by 7.3 multiply 100, so we will get the value of 1.37 or 1%. So this is the possible error in voltage. Now the in I, how much error is the error? So the error is the least count, the possible is 0.01, the total measurement is 2.73. so in percentage we will multiply it by 100, so the answer is 2%. So as we can see, the error in voltage is V and the error in current is 2, so error in R will be 2 plus 1, that will be equal to 3%. So the correct R value is 2.7 ohm plus 3% error, or 3% of 2.7. Find it and put the value, that is 2.7, and 3% of 2.7 is equal to 0.008 ohm. So this was the formula. But instead of this, in eta they will give you the error in direct, they will give you the percentage uncertainty. So R percentage error, so percentage error, percentage uncertainty is 1%, 2%, so in R it will be 3%. Now V is equal to IR, RA is equal to V divided by T, and V is equal to S divided by T, RF is equal to MA. Now what if From the given value, this was 7.3, so least count is 0.1 and this 0.001. In each case, in every case, if they give you the value of I, R, V, T, S, T, we will find this least count from given value. Like just count the number like 9.008. So write the last number replaced by 1, and for point will come its own place and the rest of number by 0. So the least count is 0.001, or 12.735 mean last number replaced by 1 and dot or point decimal will come by its position and the rest from number from 0. So 0.001 is least count. So this is the procedure to find the least count. Once you get the least count, what will you do? We will divide the least count by total value. So if they give us the value of current like 10.0 ampere, and we will get least count. So least count divided by total value give us percentage error. Or in eta they always give us the percentage uncertainty and percentage error. So if the percentage in I is 5, percentage in R is 6%, then percentage in V will be just added 5 plus 6. So it will 11% V. If percentage in V is 5% and percentage and time is 10%, so total error in A will be, possible error will be 15%. If the percentage error in S is 10% and that in T is 2%, so total error will be 12%. Like in M, if the error is 12% and if the error in A is 1%, so total error in F will be 13%. If either it is product or division form, so we will just add the percentage uncertainty. If it is divide or add, so we will just add the percentage. The next, what in case of power? So in case of power, or there comes power, like where there is power in formula, like S is equal to VIT plus half AT square, या kinetic energy, simply kinetic energy is equal to half mv square. So if there is 2% error in M and there is 2% error in V, so this is important for entry test. So the total possible error percentage and kinetic energy will be how much? So like this, if this is 5 and 6, we just add it. So this is like also same, so added. So kinetic energy is equal to half mv square, so we will add it. It will 2% plus 2%. But as we can see that this 2% is in V, so there are square on V. Square on V mean that this is V multiplied by V. So they have given us the error in V. So this is in both V. So in both V mean that 2% in this one, 2% in this one. 2 plus 2 is equal to 4. Or we will multiply this by power. So in this case, we will get the error of 2 plus 4 is equal to 6. So this is the answer. Like in volume, for volume of sphere is equal to 4 by 3 pi r cube. So a percentage error are certain, r is uncertain to up to 4%. So the error in volume is 4 multiplied by power of 3. So 4 3s are 12. So this is the error in 12, percentage uncertainty in 12. For area, area is equal to pi r square. So if this is in 4%, so we will multiply it by 4, 4 multiplied by 2. So area is equal to 4 2s are 8. So this was special case. Now this is not important, but this is uncertainty in average value. If you want to find the average value, like from example of 1.50, 1.51, 1.52. So the first case is find deviation and then find its average value, or deviation average. Average of deviation. Deviation mean how much far it from. So first we will take its average of these. So average is 1.50 plus 1.51 plus 1.53 divided by 3. So we will get 1.51. So now from deviation of these minus each and every value from this. So 1.51 minus 1.50 is equal to 0.01, or 1.5 minus 1.5 is equal to 0, or 1.5 minus 1.5 is equal to 0.01 again. So 0.01. So we will take average of these values. So add these three values and divide it by total number of values. So finding its average, it is 0.0067. So this is for that case. Now if you want to measure uncertainty in timing experiment, like this, for experiment there is time important or the experiment depends upon time. Like for example, if you want to measure time period of pendulum, so if this is pendulum, time period of pendulum means that how much time it takes to start from this position and again reach to its position. So starting from mean position going to extreme, again going to extreme and mean. So the one cycle time is called 1 second. But starting the motion, and if you click the stopwatch button, so clicking the stopwatch button and starting it, so there will be error in clicking of stopwatch. So what will we do if we say that the maximum error is 0.1 second, that either we will click it earlier or either we will click it later. So the error is how much possible? 0.1 second. Now for 1 second, the number of vibration is 1 second. So we can say that 0.1 second is the error in 1 cycle. So the error possible is 0.1. Now to decrease this value, what will we do? We will take greater number of vibration. For example, if 0.1 is the error in clicking the stopwatch, so instead of 1 we will take 10 revolution. So for 10 revolution is 10 revolution will takes place and there is no stop, pause and continuous in stopwatch. So we will measure time for 10 cycle. So in that case this is the error in the time and the number of vibration in that case are 10. So 0.1 divided by 10 is equal to 0.01. It means that we have recorded time for 10 vibration. So that error will be also divided in each value, and if we divide the error on 10, so each value will get 0.01 error. So for measurement the error is 0.01. Now if you want to accurate measure, so start the stopwatch and note the time for 1000 revolution, and then we will divide 0.1 by 100,000. So the value will be 0.0001. So in that case our error will be less. So the error or uncertainty in that case is inversely proportional to the what? Number of vibration. Possible error or so this is. Now if it covers 10 revolutions, so the time period will be, we will to find the time period we will take total time, because this is total time, and we will divide by total vibration. For example, if it took 1 minute or 60 seconds for 10 vibration, so 60 seconds it took for 10 vibration, so 60 divided by 10 is equal to 6. So it means that one vibration took 6 seconds. So this was for uncertainty in timing experiment. The next topic is dimension. The next topic is dimension. So in physics we know that there are millions, but billions are physical quantities. Like what? Like we measure mass, or also we see the measure wavelength, there is frequency, there is viscosity, velocity, also velocity, viscosity, and furthermore we can see force, we can see mass, we can see acceleration, there is a distance, there is displacement, there is a time period, there is a, and so on, simply so on. So in physics we can see millions, hundreds, thousands of quantities. Now what we know, we only know few quantities, that only we have mass, we know that we can measure the length, it is the distance, or we can measure time period, we know what is time, what is time quantity, what is length, what is mass. Next we know that such as luminous intensity, amount of substance, candle atom, tip or temperature, and so on. So in that case we will write there are two quantities, the one is basic and the one is derived. So we only know the derived 7 quantities, and all the derived quantities are made from basic quantity. So the dimension is used for dimensional analysis of derived quantity, and for dimension we can say that this derived quantity is made of basic. So how much basic combines and form that derived quantity? Like we know velocity is equal to s divided by t. So s is the length and t is the time. So we can say that 1 part L and 1 t to the power minus 1 combines and forms us the velocity. Like another we can say that A is equal to V divided by T. Again we can say that velocity is derived. So I needed N. So if someone asks me that acceleration is derived, they can tell me that of which basic quantity it is formed. So I will say that A is equal to V divided by T, and V and 10 is equal to S divided by T, and 1 T is this one. So S is the length, so T minus 2. So I will tell him that acceleration that you say that it is derived, but it itself is made of one length and 2 times that of time period. So acceleration is made of one length and 2 times time period. So all the hundreds and thousands of derived quantities are made of basic quantity. So we will write all the derived quantity in basic form, and this is called the dimension. And the most important thing is the dimension of power. So we can say that which dimension this is. Instead, now I will tell something that is important for data that is not in books. So there are, for example, 1, 2, 3, 4 are 3 forms. For dimension there are 3 to 4 forms. So how to find dimension? So we can find dimension. Trick number 1. Trick number, it is not actually trick, it is the point. So in dimension, trick number 1, we can add or subtract only those numbers which have same unit. Like 10 kg mass is equal to 5 kg plus 5 kg. Or we can add this much kg with this much kg to form this much kg. So we can add and subtract only those things which have same units. Like a body has moved to 10 meter towards north, 10 meter towards east, so total distance is 10 plus 10. So we can add 10 meter with 10 meter. We can't add 10 meter plus 10 kg. So we can only add and subtract a number that have only same dimension, that have same dimension. So the first point is same, we can add and those number which have same dimension. Like we have know that S is equal to VIT plus half AT square. So if someone asks me to tell me the dimension of VIT, so without any calculation tell him that this is the dimension of length, because S is the distance, is dimension in length. So these are two values, VIT and half AT square. So we can add these two values because they have same dimension. So AT square have also same dimension. For example, in case of VIT, V is equal to S divided by T multiplied by T, T cancel with T. So S is the dimension of length. So hence proved. Like in case of half AT square, S is equal to AT plus half AT square. In case of half AT square, half have no dimension, while A is equal to V divided by T, or V is equal to S divided by T, T multiplied by T square. T cancel with 2T, we get S, and rate of S dimension is length. Again the AT square is dimension of length. Hence proved that we can add only those quantities which have same dimension. Now if someone can ask you in eta, or there is MCQs in eta, that S is equal to XT, find the dimension of X. So we can say that to both sides must have same dimension. So S dimension is dimension of length, and XT, it means that XT must have also dimension of length. So that XT is equal to the dimension of length. Now to find the dimension of X, So we know that x is into t. So dimension of time period is t. So how can we get from x into t, how can we get the dimension of L? So in that case we can get the dimension of L if we multiply it by L and divide by t. So time period will cancel with time t and we will get L. So in that case we put the L value L by t. So the dimension of x is equal to L by t, because if we put there L by t and multiply it by t, so we will get dimension of L, that is satisfy this equation. So this was the way to find the dimension. R. The next case, if someone asks you that kinetic energy is equal to, we know that kinetic energy is equal to half mu square, but if someone tell you that find the dimension of half and he writes acceleration here, making it more tricky. There is no acceleration, but if someone asks you acceleration and then v square and then y, and now he said that find the dimension of y. So we know that kinetic energy is equal to energy is equal to half mv square. So dimension of m is equal to mv square is equal to s divided by t. So lt minus 2 is the dimension of kinetic energy. So right and left side must both have same dimension. So here we have get y a v square. So y a v square, this side must also have dimension of m l t minus 2. Now we know that a is equal to v divided by t, where v is equal to s divided by t and v is equal to s divided by t, but there is square, so I will take the square, and this is y. So y is equal to s cube divided by t to the power 4. So both sides must have same dimension. So to make, we will give such a dimension to y such that this side gives dimension of mlt minus 2. So there is s to the power 3 or l to the power 3. So to make it L, so this is L and we will write L square separately. And to make t square, so other side is 2t square, so I will write t square and t square. Now I want to remove this because both sides must have same dimension. And now I need m on this side because this side have m, so I will multiply it by m and divide it by m. Now if I want to remove these things, so to remove these things I just need multiplication by m, division by L square, multiplication by t square, such that this bracket will cancel with this and we will get our answer is lmt to the power minus 2, that is equal to mlt to the power minus 2. So if y have this value, they will cancel with this and we will get our answer. So this is high trick MCQs. Eta may not give this, but this is just a trick. Remember it, that if we add two numbers or subtract two number, so both must have same dimension. So instead of if they give x, so dimension of x is such that if we multiply it by t and we get the dimension of l. And next trick is of equality. So we can write two equation or two values such that both sides must have same dimension. So half av square y, so this av square y will be same dimension of kinetic energy. That was trick number 2. The next point to remember is, we know that work is a form of energy, or energy, there are types of energy: potential energy, kinetic energy, and so on. So if you find the dimension of energy from any equation, so all must have same dimension. For example, if you find the dimension for potential energy mgh, in second case if you find dimension from half mv square, like mgh case, mgh, where m is m, g is equal to acceleration, where g is equal to v divided by t, or s divided by t square, s divided by t square, and h is the distance, so l, so l and 12 is equal to l square. So the dimension of potential energy is equal to ml square t minus 2. Now to find for kinetic energy, so numbers have no dimension, half mv square, v is equal to s divided by t and its square, so we will take square, so we will get m L square t to the power minus 2. So this is the dimension of this. Now I know that if eta this question came in 2005, again 2010 and again 2018. So 3 times this MCQ is repeated, that what is the dimension of Planck constant. Planck constant at what? E is equal to hf, where h is Planck constant, so h is equal to E divided by f. Now we know that f, to find the frequency it is hertz, so we know that the relation between frequency and time, so frequency is equal to 1 over t, so dimension of t frequency is equal to, we can write E multiplied by t instead of E divided by f. Our energy, I don't know how to find the dimension of energy, so I will use, instead of energy I will put, for our easiness I will put W, because both have same unit, so both have must dimension. So dimension of work multiplied by time is the dimension of Planck constant. In this case W multiplied by T. So W is equal to Fd, where F is equal to MAD T, where MA is equal to V divided by T dt, M is equal, V is equal to S divided by T into T multiplied by dt. So M S D both are L square, T cancel with T, ML2 T minus 1. So this is the dimension of Planck constant. So this is the way that how to find Planck constant. The third case to find the Planck constant is that any a power must not have any unit. For example, Q is equal to Q naught e to the power minus t divided by RC. This is the equation of discharging of capacitor. So this, if we can see that e to the power minus t divided by c. So there are rules of maths that power must not have any unit, no unit. So no unit means it is no dimension. So minus t divided by RC is no unit. So it means that minus t is equal to RC. If both have same unit, so they will cancel the effect of each other, and only in that case we will get no unit. So minus t divided by RC is unit. It means the unit of t is equal to the unit of RC, and we know that the unit of t is second, so RC must also have the unit of second. So that's why we say that RC is time constant and its dimension is time. So this was all about the dimension. So it's enough for today. See you in next lecture. If you have any question, just comment on our YouTube channel or send our Facebook page, that is Bank of MCQs, or you can send us on WhatsApp on this number, that is 0342 196 3944. Just send us your dimension problem or any other problem of math chapter, of measurement chapter, and we will solve it for you. Thanks for watching, and must subscribe and share with your friends. अगर आपने हमसे कुछ सीखा हो तो this is your responsibility to share and like us. Thank you. Allah Hafiz.